Okay, welcome to slide 8. Identify the problem. So we were talking about troubleshooting. So this is in regards to troubleshooting, identifying what the problem is. When someone comes to you with like we call it trouble ticket or issue. I can't print. I can't connect to the. I've had people come to me and say, Google's not on my computer, and then you have to decipher what they mean. And it's because a lot of users don't really know what the problem is. So here we go. So the first step in the troubleshooting process is to identify the problem. During this step, gather as much information as possible from the customer and from the computer. So you're kind of just asking them, like, what do you think your problem? What do you think's wrong with the computer? Or it could just be they're having a technical issue, like they can't print, or they can't open a certain file, they can't access a certain thing, their login's not working. You want to kind of drill down to find out what specifically they're having a problem with, so you can fix that specific thing, and you're not there all day. Conversation etiquette. When you're talking to the customer, follow these guidelines. Ask direct questions to gather information. Do not use industry jargon. So if you're saying stuff like IP address to them, you've gone off the rails. You shouldn't be mentioning IP addresses to the customer, as we'll call it. You know what we're saying when we're talking about customer? We're talking about like let's take like a teacher here at the school or one of the office workers, and you're helping them fix a computer problem, right? Okay? If you're talking about printer drivers and things that we're talking about up here, you're just going to confuse them, and then the punishment for you, they're going to get confused, and you're going to be there longer than you need to be. Do not talk down to the customer, like insult them on why they can't do something, right? Do not insult the customer. Do not accuse the customer of causing the problem. Like, oh, I can't believe, what did you do? What did you click on, man? Like, you know what I mean? Don't be accusatory, okay? Figure 1 lists some of the information to gather from the customer. Over here, customer information, company name. This could be if you're like an IT company, you want to get their company name. Like they call you up and they're like, we lost all our data. Can you help us get our data back? It was all deleted. Or our website's crashed. Can you help us figure out why? Company name, the person you want to contact, the address and phone number. Computer configuration. If it's a specific computer, the manufacturer model, the OS they're running. What did we do when I went over to sports marketing a second ago to check out? What did I check? I wanted to check what operating system they were running, right? Network environment. Is it are they wired? Are they wireless? Well, that's part of the connection type, right? Problem description. Open-ended question, close-ended questions. Not sure what they mean by that. And then error messages, beep sequences, LEDs, posts. This is a lot of stuff here. But let's get into it over here and what they're talking about for each of these. We kind of know what beeps are, right? When you boot up a computer, it talks about when it beeps. The post messages, right? Tells you if you're missing a keyboard or a mouse, right? Stuff like that. Hard drives. LEDs tells you when the hard drive's spinning, right? The LEDs on the front of the computer. Okay? Any error messages that come up. So, let's see what they mean by open-ended or close-ended questions. Open-ended questions allow customers to explain the details of the problem in their own words. Use open-ended questions to obtain general information. Based on the information from the customer, you can proceed with close-ended questions. Close-ended questions generally require a yes or no answer. So open-ended would be like what? What do you think that, what's wrong? What can I help you with? And then they'll start saying, I was trying to scan this document, or I'm trying to print, and my scanner's not hooked up, or I'm trying to print something, all right? And then you could ask them, okay, what printer? Then you could say close, and it'd be like, which exact printer were you trying to print to? Because maybe they have multiple printers on their machine, and right, so they were printing to the Sharp 2010, I'm just making up a name, right? And the one that's in their room is the Sharp 2030. So they've just been printing to the office, and the office workers wondering why 700 copies of, Justin Bieber lyrics are coming out on their computer, right? And on their printer. So it's printing to a different room. So that's when you want to start to drill down. Like, okay, they're not able to print. You might ask them, what printer are they trying to print to? That could be an example of a closed-ended question. Does that make sense? Documenting responses. Document the information from the customer in the work order, in the repair log, and in your repair journal. So you keep a log of like things you talked about because you might forget. Or let's say one tech is working on, Elijah's working on a problem, but then he's off the next day, and Jeremiah's taken over, and you might want to be able to look at a log on what Elijah's done, if anything. Write down anything you think might be important for you or another technician. So he's writing a log so that this way when Jeremiah takes over, he's not starting from the beginning. Small details often lead to the solution of a difficult or complicated problem. The printing thing you're probably going to solve right away. But deeper problems where their server's not booting up anymore, right? That could require getting into stuff like this, the beep codes. We talked about this before in earlier chapters. Each BIOS manufacturer has a unique beep sequence, a combination of long and short beeps for hardware failures. When troubleshooting, power on the computer and listen. As the system proceeds through the post, most computers emit one beep to indicate that the system is booting properly. Let's turn on the computer and hear beep. If there's an error, you might hear multiple beeps. Document the beep code sequence and research the code to determine the specific problem. So this is a problem if you're having a computer that doesn't boot up. But if we're talking about, like we said, printer problems or internet connectivity, the computer's probably booted up, so we're not dealing with beep codes. But if we are dealing with a computer that doesn't boot up, we're also going to look into BIOS. If the computer boots and stops after the post, right? The post is the BIOS does the post, right? We talked about that. Investigate the BIOS settings. The device might not be detected or configured properly. So maybe it's not. It doesn't recognize the hard drive. That could be a hard drive failure, right? So it's not recognizing or recognize the hard drive and it doesn't recognize Windows, or maybe it's just not recognizing the hard drive, right? Refer to the motherboard documentation to ensure that the BIOS settings are correct. Event viewer. So now this is stuff where the computer won't boot up at all. This area, beep codes and BIOS information. Maybe there's maybe a certain computer won't boot if there's not a certain thing connected. But now we're into the computer. Because to view the event viewer, you'd have to boot into, and they're talking Windows specific. This is kind of operating system specific, the event viewer. When system, user, or software errors occur on a computer, the event viewer is updated with information about the errors. So on all these Windows computers, there's going to be a program called the event viewer. The event viewer application, shown in figure 2, records the following information about the problem. What problem occurred, date and time of the problem, severity of the problem, source of the problem, event ID number, which user was logged in when the problem occurred. So here's an example of the event viewer. You can launch this program on your Windows computer, and you'll see logs, all right, and you can view the logs. Linux has a different system, but Linux does have a log system of its own. It's just a different way you would access it. And same thing for Mac. I'm not sure how to access the Mac one, but it would be a very similar thing for a Mac. Device manager. Remember we talked about drivers? That's where you're going to find out if we talked about like certain devices like Ethernet cards require a driver. This is where you might go for that. The device manager. What does the device manager do? It manages devices. In this case, the devices are usually, the cards, but it could be a printer. The device manager, shown in figure 3. You guys ever see a picture like this on your computer? So if you're loading a graphics card, display adapter, say it, and your graphics card isn't working, you're wondering why Dorknight isn't working right, or as good as it could, you might not have the proper drivers for your graphics card, which would be right in here. Okay? This is where you'd see your printer drivers, right? Okay. Maybe your sound card, your fancy sound card, would be in here, and it would have a little thing next to it showing that there's a problem, a little check box, right? Or an X saying it doesn't. Okay, so let's read about it. The operating system flags the devices that are not operating correctly with an error icon. A yellow circle with an exclamation point indicates the device is in a problem state. A red circle with an X means that the device is disabled. Like, you can disable them yourself. A yellow question mark indicates that the system does not know which driver to install for the hardware. You might have to go to the internet, download the driver, get your fancy graphics card working correctly. Task Manager. The Task Manager, shown in number 4. You know what? We're going to take a break. I'm going to keep going. Task Manager, shown in figure 4, displays the applications and background processes that are currently running. With the Task Manager, you can close applications that have stopped responding. You can also monitor the performance of the CPU and virtual memory. So, like, here's a program right here, right? I could probably right-click and shut it down, shut down that program. So let's say one of them's using like a massive amount of CPU cycles, right? I could go and shut that down. It's great to use on like servers if something's running too hot, you know what I mean? You don't have to reboot the computer. Rebooting the computer would shut that program down. But here's a way, you've done that when you hit Control-Alt-Delete on your machine. Back in the day of Windows, you've seen something similar, you've seen the Task Manager. In Linux, we can do something like this. We run top, and it shows us all the programs that are running and which ones use the most CPU. Like OBS is using 100% of the CPU, but we probably have, which seems odd, so we probably have multiple processors. There's only 10% of it's being used. And you could do like pkill to kill stuff. So I could kill, let's see if we try something here. Let's load Firefox. So now Firefox is running, see it? So if I go to Linux, and I should be able to let's close this for a second, pkill. Let's put Firefox right here so you can see it. In theory, I should be able to kill it with just the name of the program, because if I hit tab, I'm going to hit tab right now. And there's 2 programs that begin with F. This is probably running because of the OBS, we're using the Open Broadcasting System. I don't want to kill that. And you'll see it just disappears. Okay? So pretty cool, right? So you can just kill stuff right from the command line, which is kind of nice in Linux. And Windows does it with a GUI. And there's probably a way on Windows maybe to do it with command line, but I am not sure. So with the Task Manager, you can close applications that have stopped responding. So let's say my Firefox was frozen. I could open a terminal, right? Go in, pkill Firefox, done. Then I can launch another, right? Or I could log my whole system was frozen. I could use I could log in from another computer into mine on a terminal and start killing applications. Try to bring it back to life. You can also monitor the performance of the CPU and virtual memory, view all processes that are currently running, and view information about the network connection. So you can see all that right here. Diagnostic tools. Conduct research to determine which software is available to help diagnose and solve problems. There are many programs to help you troubleshoot hardware. So if you're trying to maybe recover data, there's data recovery tools that you could download and install. Manufacturers of system hardware usually provide diagnostic tools of their own. For instance, a hard drive manufacturer might provide a tool to boot the computer and diagnose why the hard drive does not start the operating system. So there's lots of tools out there that we could use. All right, so that is slide 8. See you next time.